Okay, let's check that the sound and everything is working. We'll start in a second. Can you write an overview of the whole code? Yep. Okay, I don't need to monitor my own sound.
Get EEG data. Get EEG data handles requests to fetch EEG data based on parameters like start, count, and channel. It uses the load_data function to retrieve and send the relevant EEG data. Certainly. The provided code is part of a web application developed using Flask, a Python web framework, and JavaScript. This application is designed to process and visualize electroencephalogram, EEG, data and convert it into music. Here's an overview of the various components and functionalities of the code.
It's loading for writing for so long. ChatGPT became slower, much slower. Clear. Yeah, I'm using this voice wave ChatGPT voice control thing. So yeah, when I say yep, it should send a message. When I say clear, it should clear the text window. Clear. And it actually works most of the time if I speak properly into the microphone. Clear. 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 Okay, now it doesn't. Clear. 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 Okay, this is still generating forever. Okay, let's just read the whole thing while
Certainly. The provided code is part of a web application developed using Flask, a Python web framework, and JavaScript. This application is designed to process and visualize electroencephalogram, EEG, data and convert it into music. Here's an overview of the various components and functionalities of the code. Flask backend, Python. Flask app initialization. The Flask app is initialized, and routes are defined for different functionalities. Routes. Index route serves the main page of the application. Get EEG data. Get EEG data handles requests to fetch EEG data based on parameters like start, count, and channel. It uses the load_data function to retrieve and send the relevant EEG data. Convert EEG to music. Convert EEG to music converts the EEG data to a sequence of musical notes. This involves scaling EEG frequencies, mapping them to musical notes, and returning these notes for playback. Data loading. Load_data function reads EEG data from a file and selects a specific portion based on the given parameters. This data is then sent back to the client. Server start. The application is configured to start with debugging enabled. JavaScript front-end, main, JS. Data fetching functions. Fetch EEG data makes an HTTP request to the backend to fetch EEG data. Convert EEG to music requests the backend to convert the fetched EEG data into musical notes. Data visualization, plot EEG data function. This function uses chart.js to plot the EEG data on a canvas element. Music playback, play sequence function, plays a sequence of notes received from the backend using a sound library. MIDI and sound initialization. The code initializes web MIDI, JS for MIDI input, output, and loads a piano instrument using the sound font library. Event handling. DOM content loaded event sets up initial data fetching and plots the EEG data. It also initializes the piano sound and sets up event listeners. Slider and selector event listeners. These listeners use a debounce function to update EEG data and convert it to music based on user input from a slider and selectors. Debounce function, implemented to limit the rate at which a function can fire. This is used to control the frequency of data fetching in music playback based on slider input. Integration and workflow. The user interacts with the front end through a web interface, manipulating a slider and other controls. The JavaScript code captures these interactions and makes requests for Flask backend. The Flask application processes these requests, fetching and processing EEG data, and returns it to the front end. The front end then visualizes this data and/or converts it to music, providing an interactive experience. This overview covers the core functionalities and flow of the application. Each component works together to create an interactive platform for visualizing and solidifying EEG data.
yeah, so that's what the application currently looks like. It's loading some EEG data from file. This is actual EEG, not noise. It's an actual seizure in there. We have this in another application. Can check it out in EEG noise removal or spectrogram on the page. This is the same data. It has a seizure. In it. That's the quiet after the storm, after the seizure. You can scroll through it. Thank you, Hanzan. You're always using different names, but I do remember your photo from LinkedIn. Yeah, I was just saying how we're trying to turn EEG into music. So I'm saying this EEG is it's on ieg.org. I think anyone can download. I think it just requires a basic registration. And this particular data set has seizures in it. That's what they look like. It's real EEG. I know sometimes things like this look a bit fakeish, but no, those are seizure spikes. Check them in here. Try and reduce noise in it, which this tool does that using wavelet transforms. But now we're trying to turn this into music for various reasons. Well, one possible use case is being able to review EEG just by listening to it, and you don't want to be listening to sinusoids because it's annoying, noisy. It will just sound like noise, so you might as well turn it into music. Or, well, when I say music, it might not be perceived as music, but instead of sinusoids, it's actually using musical notes. So notes like this is just for testing. So actual F#6 or G6. So it will find this code, which GPT4 generated for us, will actually do a conversion using an interpolation. So we're trying to fix this code, however. That's the general idea. I'm getting all sorts of errors with it, mainly to do with the fact that the frequency components cannot be directly translated into a musical note because it will be essentially outside the range of a typical piano, for example. Now here we're using a grand piano. So that interpolation, well, it does work, but it's generating this. Yeah, I'm not sure why the algorithm cannot find these particular notes. I'm not sure if it's because they're not defined here. I was testing it last time. We're having this other error as well, which is meant to prevent us sending the same thing multiple times. So let's solve this one first. That's the error description.
The error uncaught reference error. The bounce is not defined indicates that the bounce function you're trying to use is not defined in your main.js file or is not properly imported from an external library. The debounce function is a common utility in JavaScript used to limit the rate at which a function can fire. This is particularly useful for events that can occur more frequently than you might want to handle them, such as window resizing, scrolling, or, in your case, input from a slider.
Actually don't have the function clear. This doesn't work. Clear. Right, it did work. Yeah, it's a hit and miss. It must be my pronunciation that the bot is not picking up. So are we trying to define our own debounce function? Don't we have and the bounds available somewhere already. Bounds currently an event list now. So we have the bounds 4 times and the code is throwing an error. Yeah, we have a bunch of errors. Minor errors like warnings. This one, main.js 178. Bounds function. Okay, we do need to define a function. This is what this code does. So we will pop it in here. And in the use of the function, we have the bounds update data, convert to music in 500 millisecond delay. That looks good. Also, data slider, and this line should be the same as it is. Yeah, let's try it again. Should not. Okay, Control F5. We already have. Bounce function. Have the overview of the whole code. Okay, what the problem is. What is the problem is. Let's format document. Function there should be okay. I don't know what the can use Copilot. Still getting this error. Didn't realize Yeah, I suspected that, but I didn't realize JavaScript works that way. That you need to define, this function is actually not being used. Define a function before it's being used. That's odd. That's very odd. So we need to place it here somewhere. Okay, Control F5 again. What are all this? Okay, that error is gone. Okay, I'm still getting the buffer node, so the nodes would not play. That needs to be sorted out. Yeah, so the idea is that this EEG, real EEG, will be translated into musical notes. Let's reduce the window size for a sec. So as you scroll through the EEG file, it will convert it to, well, music. I'm not saying it will sound like music, but it will be converted to actual, currently using a musical font called Grand Piano. So it will be converted into something like this. But we're having all these errors coming through. Let's just messages, warnings, audio context was not allowed to start. I'll try to resolve it both using GitHub Copilot and GPT4. See what both say. Modern browsers, security. Yeah, I like how GitHub Copilot already gives a resolution. Yeah, GPT4 does the same. And more. Okay, we actually need all this. Let's read this quickly. Can't read myself, I need the speech.
The error message you're encountering, the audio context was not allowed to start. It must be resumed, or created, after a user gesture on the page, is a security feature implemented in modern web browsers. This feature prevents audio from playing automatically when a web page loads, which can be intrusive or annoying to users. As a result, an audio context in Web Audio API needs to be initiated or resumed in response to user interaction, such as a click or a tap. To resolve this issue, you should modify your JavaScript code to create or resume the audio context only after a user gesture. Here's how you can do it. Create the audio context lazily, instead of creating the audio context immediately when the page loads. Create it when the user first interacts with the page. Resume the audio context on user interaction. If the audio context is already created but is in a suspended state, resume it in response to a user gesture. Here's a revised approach that you can integrate into your main.js file.
Yeah, so some sort of browser feature. Okay. So hopefully this tool will soon appear on biomedical.com. It currently has all these other tools. This tool is actually the EEG noise reduction is using the same data. So you can check it out, let know what you think. And hopefully this one will appear there sometime this week. Or am I too optimistic? So let's check the code.
With these changes, the audio context will either be created or resumed in response to a user action, like a click, complying with the browser's security policies. This
Right,
should resolve the error you're experiencing.
Right, so that's something that's it sounds like we need to fix. Do we have a resume? Yeah, I won't be able to integrate this because I don't actually know JavaScript. Can we ask GPT4 to integrate? So essentially generate updated was it main.js? I won't be able to integrate it myself. Just create a copy. We already had a few copies. We can get rid of those. They were from last week. Copy this one because that's the one we will be changing. Yeah, we need to handle an audio context because I'm getting this warning that the audio context is not allowed to start unless there is an interaction with the page. It's actually working okay, but yes, we're getting, so need to get rid of that error. Let's make the window size smaller again. Try this again. The main problem is that, well, we can't hear those notes. That's obviously because of this comment here. The buffer for node name is not found. So it's the kind of the real problem. Let's copy that. Are there any placeholders? And no, not yet. It's still generating the code. By the way, if there's any comments, suggestions, requests, I'm more than welcome. Yes, I thought we're not using the web media anymore because that was generating a file. And it didn't finish, did it? There's a continue button. used to be clearer on the bottom of the page, continue generating. Now it's on the bottom right. Yeah, they changed the interface quite a bit. All my previous chats are in this 2-line burger icon, top left. So it's finished generating. Let's see what it says.
The audio context is now created or resumed in response to user interaction, as per the security policy of modern browsers.
Right, so it sounds like we won't be able to bypass security of modern browsers, and we kind of don't want to anyway, so we'll have to implement this.
The play sequence function is updated to get or create audio context and pass it to the play method of the piano.
Okay, that sounds legit.
A click event listener is added to resume the audio context when any click occurs on the document.
Right, well, can just try it. It's a shorter code, 198 lines instead of 200 lines from prior. Save this. So this at least should get rid of this audio context warning thing. Control F5. So music is still running. Let's reduce the window size to 10. This should already play some notes. It's not doing it. And let's copy a bunch here. I can't hear anything and get the following.
The error messages you're seeing, such as buffer for note E6 not found, indicate that the SoundFont library is unable to find the audio buffers for the specified musical notes. This usually happens when the specified notes are not available in the loaded SoundFont instrument, or if there's an issue with how the notes are being referenced. Ensure that the node names being generated by the backend and sent to the front end are compatible with the SoundFont library's naming conventions. For instance, SoundFont typically uses node names like C4, D#4, F5, etc. If the backend generates node names in a different format, they might not be recognized by the SoundFont library. Different SoundFont instruments may have different ranges of notes they can play. If your EEG to music conversion algorithm generates notes outside this range, you will encounter errors. One solution is to limit the range of notes generated by your algorithm to match the range of the loaded SoundFont instrument.
Yes, it's grand piano. Well, I mean, that's why it's called grand piano. It should have a wider range of notes, of keys.
Make sure the SoundFont instrument is loaded correctly before trying to play any notes. You can check this by logging the loaded instrument to the console and ensuring it's available when play sequence is called.
I'm pretty sure it's working okay because we have this button for testing is actually playing sound.
Modify the play sequence function to handle cases where a note buffer is not found. You might want to skip the notes that are not found or handle them differently. In this revised function, if a note buffer is not found, it logs a warning and skips to the next note, rather than stopping the entire sequence. This should allow the sequence to continue playing even if some notes are missing.
Okay, can we do this? It's probably, well, hopefully that is the problem, is the names. Do we have names? node names.
To verify that the node names being generated and sent to the front end are compatible with the Salfant library's naming conventions, you should follow these steps. Check backend node generation. First, ensure that the backend, your Flask application, generates node names correctly. The standard naming convention for notes in most music libraries, including Salfant, is like C4, D#4, F5, etc., where the letter represents the note and the number represents the octave. Inspect the data sent to front end. Look at the data being sent from the back end to the front end. This can be done by logging the data, notes array in your convert EEG to music function in the JavaScript file. Add a console.log statement to print out the notes.
Check the Python code. So what happened there? It's normally errors.
To verify if the node names generated in your Python code are compatible with the Salfant library's naming conventions, we should review the relevant portion of your Flask application where these names are generated. The key part is in the convert EEG to music route, where the EEG data is converted into musical notes. Node name generation. Ensure that the node names are in the standard format, like C4, D#4, F5, etc. This format is typically a letter, a G, optionally followed by sharp, hash, or flat, B, and then the octave number. Node range. Verify that the notes fall within the range supported by your Salfant instrument. For a standard piano, this range is usually from A0 to C8. Node frequency mapping. Make sure the mapping from EEG data to musical notes is correct and that it produces valid node names.
Is this my code?
The node names are generated in the format note plus octave, e.g., C4, D#5. This seems to align with the standard naming convention.
So we have this line here. That's the same. Then we have node labels. It's the same.
The notes are generated within the range of C3 to C6, which is typical range and should be supported by standard piano Salfant. The conversion from EEG frequencies to musical notes uses linear interpolation. Ensure that this mapping does not produce indices outside the range of node underscore labels. The code appears to generate the correct format of node names. If you're still encountering issues, you may need to further investigate the specific node names causing errors and confirm they're being generated correctly and exist within the Salfant instruments range.
Do that, yeah, we need some troubleshooting. It was working okay. So it's doing a 1D linear interpolation. Let's clear this for a sec. Clear the console as well. So we have a window size of 10, selecting another region of the EEG. The nodes are B5. It's generated twice. Should have been generated twice. And we don't hear the note played.
After logging the generated notes, verify if all of them fall within the range of the sound font instrument. For a standard piano sound font, this range is typically from A0 to C8. Manually check a few of the logged notes by playing them with your sound font instrument. This can be done by hardcoding these notes in your JavaScript play function and seeing if they produce sound.
This is an output, that's not a bad idea. We can go link this to B5. Play MIDI. Let's do a B5. It's playing okay.
The log data you provided shows that the scale of the EEG frequencies are being mapped to the same musical note, B5, for every data point. This could be happening due to the way the frequency to note conversion is being handled in your Python code. Let's look into a few potential reasons and solutions.
So that's fine, but first it's not playing at all. This code is working okay. It is playing a B5. However, previously B5 said not to be available in the buffer or something. Yep.
The sound font instrument might not be fully loaded when you're trying to play the notes initially. This can happen because the loading of sound font instruments is asynchronous. If there are multiple instances of audio context, or if the context used to load the sound font instrument is different from the one used to play the notes, this could lead to issues. Solution: ensure you use the same audio context instance for both loading the instrument and playing the notes. If there are multiple instances of audio context, or if the context used to load the sound font instrument is different from the one used to play the notes, this could lead to issues. If the audio context is in a suspended state when you try to play the notes initially, but later, when you click the button, it is in a running state, this might explain why the notes play correctly on button click but not initially. Here's a revised snippet that ensures the piano is loaded and the audio context is in the correct state before playing notes.
change the code, there's something wrong. So the music is being played here. B5 is okay, but it's not playing when we scroll through the EEG signal. Conversion is a different point.
In this revised code, the piano ready flag ensures that the piano is only used after it has been successfully loaded. Additionally, the audio context is consistently managed to ensure it's in the correct state before playing any notes.
This audio context thing. It's not being used correctly. You regenerate whole AJS. Yes, this is updated JavaScript. Loading piano, loading this grand piano. So it should have all the keys. That error that we were getting should go away. Yeah, fetching AG, updating the data. This is happening when you're scrolling, or essentially pressing any, changing any input on the front page, plotting the data, converting to music. It's using a now function. It should be legit. Currently we have yet 200 lines of code. This is shorter because I haven't finished. Have to click this button for it to continue generating. Yeah, debounce function should prevent the user from clicking too many times. So now the piano is working, the EEG is working, it's loading okay, but we're still having this issue with the buffer not found. do a Control F5. Use the window size just so we're not overloading the thing. We'll select piano is working. Let's see, sharp or something. This button, play MIDI, Control F. This code, yeah, it's B5. It's working okay. This code. This code is. Did I say this code? This code is working okay. B5 is being played when button is pressed. However, I still get the following errors. Fix the code. I'm pretty sure sometimes the send response is just working with enter button, and other times you need to actually press the button on the screen.
If the window, piano, play, B5 command works correctly when triggered by button press, but you're still receiving buffer for node B5 not found messages during other parts of your script, there are a few potential causes and solutions to explore. Check for multiple instances of audio context or the sound font instrument. If there are multiple instances of audio context or the sound font instrument, the instance used for playing notes may not be the same as the one used for loading the piano. Solution: ensure that you're consistently using the same instance of audio context and the sound font instrument across your script. Avoid reinitializing the piano or the audio context multiple times.
Okay, how do I actually do that? That's obviously in JavaScript. We have audio context. Getting a network error. How to fix the code? Or just fix the code? Please don't give me network errors. So obviously the piano is working, as you can hear. But then in other parts of the code it's giving me buffer node not found.
To ensure consistent use of the same instance of audio context and the sound font instrument, piano, across your script, you should manage their initialization and state carefully. Let's modify your main.js to achieve this. Single instance of audio context. Initialize audio context only once and use the same instance throughout the script. Check piano loading state. Make sure you only attempt to play notes after confirming that the piano has been fully loaded and is ready. Avoid initialization. Prevent any initialization of the piano or audio context after they have been set up.
Okay, so that code is the same. Giving me all the code that haven't changed. Play sequence. Play sequence nodes. Again, this is the same thing. Play next note. Okay, she added this if condition window piano buffers note. Okay, so that message is actually coming from the code, so that's good to know. Play next node, document get element by ID. This should be the same. Document event list loaded. Load piano. Deep bounce. Let's read this quickly.
Get audio context ensures that only one audio context instance is created and used throughout the script. Load piano checks piano ready before attempting to load the piano to avoid initialization. The play sequence function ensures that it only plays notes if the piano is ready. Piano ready is true. By structuring your script this way, you avoid issues caused by multiple instances or states of audio context in the piano instrument, ensuring more reliable and consistent behavior in your application.
Nope, still skipping. And the piano is still working with B5. I need that prompt. Put this prompt at the bottom. That's a comment. Okay, this is a bit of a desperate move. We'll just pop this whole code into GPT4. We'll try Copilot as well. So doing explain this so it has access. Okay, we can stop that. Pop this code, that prompt into Copilot as well.
This function now includes more detailed logging and checks the readiness of the piano before playing each note. If the piano is not ready, it logs a message. You can expand this by implementing a more sophisticated waiting mechanism, like a callback or an event listener, that triggers note playing once the piano is confirmed to be ready.
What did Copilot say? Sound from instrument functional. Seem to load the piano sound returns a promise that resolves to an instrument object. This object has a play method. However, before you can play a note, the audio data for the note needs to be loaded into the audio buffer. The issue might be that the audio data for the note B5 has not been loaded when you are trying to play it. Has not finished loading. Could ensure that the piano sound is fully loaded before trying to play a note. But that code is actually working. That's what I said, didn't I? Said that the window piano play B5 is working okay. Yeah, GitHub Copilot. Doesn't have the context. Seems to be a little.
This function now includes more detailed logging and checks the readiness of the piano before playing each note. If the piano is not ready, it logs a message. You can expand this by implementing a more sophisticated waiting mechanism, like a callback or an event listener, that triggers note playing once the piano is confirmed to be ready.
Yeah, GPT4 is not giving an answer, but at least it understands what I'm trying to do.
The issue where buffer for node B5 not found error appears, despite being able to successfully play B5 when a button is pressed, suggests a potential timing or state synchronization issue between the loading of the piano instrument and its readiness to play notes. Here are a few additional steps to troubleshoot and resolve this issue. 1. Ensure play sequence waits for piano readiness. Modify the play sequence function to explicitly wait for the piano to be ready before attempting to play any notes. This can be achieved by checking the piano ready flag and using a promise or a callback to delay the note playback until the piano is fully loaded. 2. Debugging logs. Add debugging logs to various parts of your code to trace the state of the piano ready flag and the window, piano object. This will help you understand if the piano is indeed ready and available when play sequence is called. 3. Verify window, piano, buffers. Ensure that window, piano, buffers is correctly populated with node buffers. It's possible that the node buffers are not being loaded as expected, which could cause the error. 4. Loading sound from instrument. Double check the sound from instrument loading logic. Ensure that the instrument is loaded just once and that any subsequent calls to play notes are made after this loading is complete. 5. Error handling in play sequence. Improve the error handling in the play sequence function to gracefully handle cases where the node buffer is not found.
Yeah, let's do some more troubleshooting. Some advanced debugging. Okay. Yeah, I'm going in circles. Obviously, it does have c6. So now we're doing b5. Let's do c6. Piano loaded. Now the sound font is okay. Loading is okay.
There might be network issues or file access issues preventing the complete loading of all node buffers. Check the network requests in your browser's developer tools to see if all requests related to the sound font loading is succeeding. Enhance your debugging by logging more information about the loaded sound font instrument. Specifically, inspect the window, piano, buffers object to see which notes are available.
Can I close this for a sec? Yeah, the terminal is not giving anything useful. Just restart the app entirely. Piano loaded. We know it's loaded because it's also playing tones. To restructure this code, it should be playing these tones. Okay, let's start a new chat quickly. We have the prompt, the bottom as well. Maybe a fresh start will help because we're going over an hour trying to fix this, what meant to be a simple fix.
It seems you're facing an issue where the piano buffer for node B5 is not found, even though the note is being played. This indicates that while the audio for B5 is available and playable, the program is either not correctly recognizing the buffer or there's a discrepancy in how the buffer is being accessed or stored. Here are a few. Check buffer initialization. Ensure that all node buffers are being initialized correctly when the piano is loaded. This might involve checking if each note, including B5, has a corresponding buffer created in window, piano, buffers.
Okay.
Buffer access logic. Examine how the buffers are accessed in a play sequence function. The warning buffer for node B5 not found suggests that when window, piano, buffers, note, is evaluated for B5, it returns undefined or null. There might be an issue with how the notes are being passed or indexed.
Just continue. Yeah, I have notes work okay. I meant continue with debugging.
Loading all buffers. Verify the sound font. Instrument is loading all the necessary buffers for each note. There could be a limitation or error in how the buffers are being loaded, especially if you're only loading a subset of notes. Alternative loading strategy. If the problem persists, consider a different strategy for loading instruments or notes. For instance, you might load individual note buffers separately rather than relying on a single call to sound font, instrument. Inspect network activity. Use your browser's developer tools to inspect network activity when the piano is being loaded. Ensure that all necessary audio files for the piano notes, including B5, are being successfully downloaded. Missing or failed downloads could lead to missing buffers.
Yeah, that's probably the best advice.
Simplify and isolate. Simplify your code to the bare minimum required to load and play a single note. This can help isolate the problem and rule out any other factors. Your app.py script for the Flask application seems to be mostly set up correctly for handling EEG data and converting it to musical notes. However, there are a few potential improvements or clarifications that might help fix any issues you're facing. Here are error handling in routes. In your get EEG data and convert EEG to music routes, you're catching exceptions but not logging detailed information about them. It's useful to log the stack trace for easier debugging. Use traceback, print_xe, within your exception box to get more detailed error information. Data loading in load_data function. The load_data function assumes a specific format and location for the EEG data file. Make sure that the file path and format, delimiters, headers, etc., match your actual data file. Also, check if the skip rows and NROWS parameters in PD, read_CSV align with your data layout. Scaling EEG frequencies. The scaling of the EEG frequencies to musical note frequencies is a critical part. Ensure that the scaling factor and the interpolation logic correctly map EEG frequencies to the musical note range you've defined. Test this part separately to confirm it's working as expected. Handling edge cases. The conversion logic in convert_EEG should handle edge cases, like when EEG data is empty, contains anomalies, or results in indices outside the range of node_labels. Make sure these cases are handled to prevent runtime errors. Debug logs. You have commented out some debug logs. It might be helpful to uncomment these logs for troubleshooting, especially to verify the input parameters and the intermediate outputs at various stages. Configuration of the Flask app. The commented out configuration for template_folder and static_folder in the Flask app initialization might be necessary if your templates and static files are not in the default locations. Make sure the paths are correctly set based on your project structure. Data structure in load_data. Ensure the data structure returned by load_data is compatible with how it's used in the rest of your code. The function returns a list of lists, where each inner list contains a data point and its corresponding time. Confirm that this structure works well with your EEG data plotting and music conversion logic. Front-end integration. Ensure that the front-end JavaScript code making requests to these endpoints handles the responses correctly. Especially, it should be able to handle error responses and display appropriate messages or fallback behavior. Testing and validation. Test each part of your application independently. For example, test the data loading and conversion logic separately from the Flask routes to isolate issues. Performance considerations. If your EEG data files are large, loading and processing them might be slow. Consider optimizing this part, perhaps by pre-processing the files or using more efficient data structures. App deployment and environment. If you're deploying this application, ensure that the environment, like file paths and available libraries, is correctly set up. Sometimes issues arise due to differences between development and production environments.
Probably gonna get penalized for long prompts. Probably gonna get a timeout.
The issue you're experiencing where the piano buffer for B5 is not found, yet the note is being played, suggests a potential inconsistency or error in how the sound font library is handling the buffers for piano notes. Here are some specific steps to troubleshoot and fix this issue. The first thing to verify is whether the sound font library successfully loads all the buffers for piano notes, including B5. You can add a debug statement to inspect the window, piano, buffers after the piano is loaded. Check if the buffer for B5 is indeed missing or not correctly initialized. After the piano is loaded, inspect the specific buffer for B5. If a specific note's buffer is not found, you can handle this case more gracefully. For instance, skip playing the note or show user-friendly message. Make sure that you are using the sound font library according to its documentation. Check if there are any specific steps or configurations needed to ensure all note buffers are loaded correctly. As a diagnostic step, try loading a different instrument to see if the issue persists. This can help determine if the problem is with a specific instrument, acoustic_grand_piano, or a more general issue with the library. If you are using an older version of the sound font library, consider updating to the latest version. Sometimes bugs related to buffer loading and handling are fixed in newer versions. If the problem persists, it might be a known issue with the library. Check the community forums, GitHub issues page, or other user discussions related to the sound font library for similar problems and potential solutions. If you continue to face issues with the sound font library, you might consider using alternative libraries or methods to achieve your goal. To resolve this, you should initialize or resume the audio context inside a user-initiated event handler. For example, you can add a button on your web page for users to start or resume the audio, and in its event handler, call get audio context or resume audio context. It appears that the buffers for certain nodes, like B5, C6, etc., are not being loaded or found. This could be due to several reasons. The SoundFont library might not provide these specific notes, or there could be a mismatch in the naming convention used by the library in your code. To fix this, you need to ensure that the node names you're using match exactly with what the SoundFont library has loaded. Node names are often case-sensitive and might include octave numbers that need to match. For instance, B5 in your code should exactly match the naming used in the SoundFont buffers. You can add a check to see if the note exists in window, piano, buffers before attempting to play it. If the buffer does not exist, you might need to handle it gracefully, either by skipping the note, providing a fallback, or by investigating why the buffer was not loaded. In this example, Start Audio would be the ID of a button on a web page. When clicked, it initializes the audio context, ensuring compliance with browser security policies regarding audio playback. In this updated playNextNote function, there's an additional check to see if the window, piano, buffers object has the property corresponding to the note being played. This ensures that you're only attempting to play notes for which buffers exist. By implementing these adjustments, your application should handle the audio context and missing buffers more effectively. Ensuring that node names in your code match exactly with what the SoundFont library has loaded is crucial for the correct functioning of your audio playback. Here's how you can verify and adjust your code to match the node naming conventions used by the SoundFont library. Review library documentation. Check the SoundFont library documentation for information on how node names and octaves are represented. This often varies between libraries. Inspect loaded buffers. If the documentation is unclear, you can inspect the window, piano, buffers object after loading the instrument. Log the object and examine the keys to understand the naming convention used. For example, case sensitivity. Ensure that the case of the node names in your code matches that used by the SoundFont library. For example, if the library uses uppercase letters for node names, e.g., C, D hash, B, your code should do the same. Case sensitivity. Ensure that the case of the node names in your code matches that used by the sound font library. For example, if the library uses uppercase letters for node names, e.g., C, D hash, B, your code should do the same. By taking these steps, you can ensure that the node names used in your code match the sound font library's naming convention, thereby avoiding issues with missing buffers and ensuring smooth audio playback. Case sensitivity. Ensure that the case of the node names in your code matches that used by the sound font library. For example, if the library uses uppercase letters for node names, e.g., C, D hash, B, your code should do the same. Octave numbering. Verify how octaves are numbered in the library. Some libraries might start counting octaves from 0, while others start from 1. For example, if C4 in a library is middle C, ensure your code refers to it as C4, and not C3 or C5. Sharp and flat notations. Confirm how sharps, sharp, and flats, flat, are represented. Some libraries might use hash for sharp and B for flat, while others might use different representations. The data you've provided shows that the sound font library has loaded a range of audio buffer objects, each labeled with a number from 21 to 108. These numbers most likely represent MIDI node numbers, which is a common way for musical software and libraries to refer to notes. Understanding MIDI node numbers. MIDI node numbers are a standard way to refer to musical notes in the context of digital music and synthesizers. Each number corresponds to a specific musical note, with middle C typically represented as 60. The numbering generally starts at 0, which is often C1, several octaves below middle C, and goes up to 127. Adjusting your code. To play notes using this library, you need to use these MIDI node numbers instead of traditional node names like C4, B5, etc. Here's how you can adjust your code. Convert node names to MIDI node numbers. Create a function that converts traditional node names to MIDI node numbers. This function will depend on how you're currently representing notes in your code. Adjust play sequence function. Modify the play sequence function to use MIDI node numbers when calling window, piano, play. Example conversion function. Here is an example of how you might write a conversion function, assuming you are starting with traditional node names like C4, B5, etc. Here's how you might adjust the play next node function. By making these adjustments, your code should be able to correctly reference and play the notes using the MIDI node numbers provided by the sound font library. potential improvements and considerations. Ensure that the EEG data file path and format match your actual data. The scaling and mapping of the EEG frequencies to musical notes might need fine-tuning to ensure meaningful musical output. Consider adding more comments throughout the code for clarity, especially in complex sections like the EEG to music conversion. Ensure error handling is comprehensive, especially for edge cases like incorrect data formats or out-of-range values. Your HTML code provides a user interface for an EEG to music application. It's designed to allow users to interact with the EEG data and listen to music generated from it. Below is an analysis of the key components of your HTML. Head section, the back quote less than. The less than head greater than includes the title of your page, but lacks other meta tags, like viewport settings for responsive design, and external starsheet links if you plan to use them. Contains a simple header with a welcoming message. Includes an audio player that is intended to play MIDI files generated from EEG data. This uses Flask's URL_ for function to dynamically set the source URL. A button, id = play MIDI, is provided, likely to trigger music playing through JavaScript. There is a less than canvas greater than element for presumably displaying EEG data graphically, possibly as a chart. Channel selection and window size inputs are provided to allow users to customize the data they're viewing or listening to. A slider, id = data slider, to navigate through the data. The max value of the slider is set to max_value, which should be dynamically set based on the data length. Includes attribution for the EEG data source and a copyright notice. You have included scripts for chart.js, for data visualization, WebMIDI, for MIDI functionality, SoundFont player, for audio playback, and a custom script, main.js. The commented out scripts suggest you might have experimented with different libraries or are considering alternative options. Add responsive design meta tags in the less than head greater than section for better mobile device compatibility. Consider adding error handling in your JavaScript for scenarios where the EEG data cannot be loaded or the MIDI playback fails. Validate user input for the channel selector and window size to ensure they're within expected ranges. Ensure max_value for the data slider is dynamically set based on the actual data length to avoid runtime errors. If your application has a style sheet, include it in the less than head greater than section. Organize your JavaScript files and libraries for better maintainability and load performance. Overall, your HTML structure is clear and functional, providing a good foundation for the EEG to music application. Ensure to test the application across different browsers and devices for compatibility. The issue you're encountering, buffer for note, not found. Skipping suggests that when the play sequence function attempts to play a note, the corresponding audio buffer for that note is not found in window, piano, buffers. This could be due to several reasons. Let's address this issue with a few potential solutions. Ensure proper note format. Verify. Verify that the notes in your array are in the correct format that the SoundFont library expects. For example, if your library expects note names like C#4 or D-flat4, ensure that your notes match this format exactly. Preload all required notes. Modify your load piano function to preload all the notes you plan to use. By default, SoundFont may not load every single note for a given instrument to save memory. You can explicitly load certain notes or an entire range if needed. Check for SoundFont completeness. Some SoundFonts might not have every note, especially at the extremes of the range. Check the SoundFont you're using to ensure it includes all the notes you need. Add more console logs in the load piano function to verify that all the required notes are being loaded correctly. Specifically, check for the notes that are giving the buffer not found error. Enhance the error handling in the play sequence function to gracefully handle cases where a note's buffer is not found. Consider skipping the note or substituting it with a different note if its buffer is not available. Make sure you are using the latest version of the SoundFont player library, as there may have been fixes or improvements related to this issue. Here's an example of how you might modify the load piano function to preload a range of notes. In this modification, I specified a range of notes to be preloaded. Adjust the array of notes to include all the notes you require. Ensure to test the modified function to confirm that all required notes are being loaded successfully. The error messages you're encountering indicate two separate issues. Audio context not allowed to start. This is a common issue in modern web browsers, which require an audio context to be initiated as a result of a user action, like a click or a tap, to prevent unwanted audio playback. Buffer not found issues. These errors occur when the SoundFont player tries to play a note for which the buffer has not been loaded. Let's address each issue separately. You need to ensure that the audio context is created or resumed in response to user gesture. This means initializing the audio context or calling the resume function in an event handler for a user action, like a button click. For example, preloading specific notes. As mentioned before, ensure that all the notes you plan to play are preloaded. If you are dynamically generating notes, for example, from EEG data, you might need to load a wider range of notes. Checking note names and formats. Make sure the note names used in your code match those used by the SoundFont library. For instance, B5 should be the correct format, but it's worth double-checking for typos or format mismatches. Handling missing buffers gracefully. In your play sequence function, before attempting to play a note, check if the buffer for that note exists. If not, you can choose to skip it or log a warning, as you are currently doing. Debugging loaded buffers. Add console logs to inspect which buffers are actually loaded after the SoundFont loads. This can help you identify if there is an issue with the loading process itself. SoundFont library version and compatibility. Ensure that you are using a compatible version of the SoundFont library with your notes and audio setup. By addressing these two issues, your application should be able to initiate the audio context correctly upon a user action and handle cases where a note's buffer is not found more gracefully.
Okay, there seems to be an issue of how we actually using this JavaScript for playing sounds. Trying to understand what's the difference between the mean JS and the regular JS. So it is using median node numbers. Okay, and we also got a timeout from GPT4 as expected. There's no option to regenerate though. Documentation, an API. Yeah, really trying to avoid reading PDFs.
The SoundFont Player NPM package is a library that allows you to play MIDI sounds using the Web Audio API. It is a simple and lightweight alternative to more complex libraries like MIDI.js, providing an easy way to load and play SoundFont files in either MIDI.js format or JSON format. Here's an overview of its key features and usage. Load SoundFont files. It can load SoundFont files in both MIDI.js format and JSON format. Unlimited polyphony. It supports unlimited polyphony and allows stopping all sounds with a single function call. Note playing, accepts MIDI note numbers and also supports decimal points for detuning. MIDI connection, easily connect to a web MIDI API MIDI input. Note scheduling, schedule a list of notes. Using Audio Loader and Sample Player, it uses Audio Loader to load SoundFont files and Sample Player to play the sounds. You can install SoundFont Player via NPM or include it directly in your HTML. Loading an instrument, JavaScript copy code SoundFont. Instrument, AC, clavinet, then, function, clavinet. Clavinet, play, C4.